Today we're going to demonstrate the use of the pleo PD lock extension osteotomy plate for distal femoral extension osteotomy for knee flexion contracture. The indication for this is usually going to be a patient who walks with bent knees. Most of the time it's cerebral palsy. There are other reasons that children will have bent knees, and you can do an osteotomy to straighten out their knees, and you can also rotate the bone at the same time. So as we start, we select the right plate size for the patient, and looking at the bone, this is going to be the smaller fragment size that will fit. And we're going to have 3 holes at the distal part of the osteotomy in the distal fragment, and we'll have 3 holes in the proximal fragment. Sometimes this hole in the middle here will be at the level of the osteotomy. And you want to have 3 screws above, 3 screws below. So as you start with our dissection, we'll make a lateral approach to the femur, and it's very important to avoid the growth center. The physis, the lateral growth plate, is right down here. And as you come down, you want to get very close to it, but not onto it. So once you dissect that down, you come down right next to the growth plate. You'll take your guide, and you'll align this guide with the amount of flexion the patient has. So the femur's coming down this way, and the tibia is here. And so if the patient is 30 degrees bent, you will align this right along the shaft of the tibia. Then we'll start by putting a guide pin through the hole, and there's a lot of play in this hole. So really what we want to do when we start this is it's more of a hold for proximal distal, because now we know we're not going to drift down onto the growth center. And then we'll take our locking guide, place it through the hole, and we will drill that first one. Here, before you drill this one, now is where you're really making sure you've got your angle just quite right. And you still have one other opportunity to fine-tune this. You're watching with X-ray to make sure that this drill does not go across the growth center here. You can measure right off the drill right here for the length of the screw, or you can use your depth gauge. Now as you use this depth gauge, if it goes all the way into the plate against the bone, your screw will measure a little bit shorter, as opposed to if the depth gauge goes right up against the plate. So this measures 44. And what I'll often do is start with a regular screw. And you don't have to do this, but I start with a regular screw so that I know that it can lock the plate right down against the bone, because your locking screw is going to hold the plate wherever, even if it's a little bit off the bone. And so now that I've got that, I will take out the guide pin, and at this point place a second locking tube and my final absolute measure of how much flexion extension I want to get out of here, because it's just very easy for this to drift 5 degrees up, 5 degrees down, and this measure is really quite precise. And so we'll measure either off the drill or with the drill guide. 42. And now you can start to use your locking screws. And so you just keep track of the length so that you would change this one eventually to a locking screw. The bone in the distal femur is generally not very strong, especially in children with cerebral palsy. So the advantages of this system is each of these is a locking screw, and it gives you very good hold. As you're putting these screws in, they may look like they don't go all the way through the bone, but remember, the shape of the femur is not always a tube, and down here the shape of it is more like a trapezoid. And so you want to be careful to make sure your length is accurate, and it doesn't always have to look like it's through on your AP C-arm X-ray. Final step is putting in the last screw. I'm going to call that 36. Okay, now we've got this, and once we have this, our angle of our osteotomy is already predetermined, because when we put the plate on in this direction and we cut our wedge of bone, it's already going to determine just how straight the distal femur becomes. It's not always necessary to take out a wedge of bone in the distal femur. You can just cut the bone, and they don't have to be perfectly end-on apposition. However, as you're doing this, you're increasing the length along the back, which will stretch the sciatic nerve. So you want to be very careful of that. And usually I will take out some bone, and commonly we're doing this bilaterally so I can equalize their leg lengths later. The more important part of this procedure is not to stretch the sciatic nerve. Okay, so the first cut we're going to make is going to be perpendicular to the femur, but the angle will be right along there. That means our screw will still have good purchase, and we're already starting to take out the wedge of bone. So before I go all the way through, I just want to show that once I've got that cut, the next cut will be perpendicular. And again, this angle should be exactly the angle of the distal femoral extension that we want by placing this guide. So I can either take out a wedge, or I can take out a trapezoid, and it depends on how much correction I'm going to do and how tight I think the hamstrings are and how much stretch I think I'm going to get on the sciatic nerve. And so you can see as we look at the angle here, I've taken out just a tiny trapezoid, basically just a triangle, but this angle should equal the distal femoral correction that we are hoping to achieve. Then we'll remove our screws from the guide. And we keep track of which one. So this is our proximal most screw. This is our anterior distal, and this is our posterior distal screw. The next step is to select our plate, and so we'll create our reduction. We want to check the plate for frontal plane varus valgus. We want to line this up. Sometimes, because the way the plate is designed, since we're staying away from the growth center, will cause a little bit of varus or valgus. And so having a large plate bender just to take out a little bit of the valgus or put in a little bit more valgus, because this alignment is going to be very noticeable. So we'll take our plate, and let's assume that this one is correct. And what I first take is my non-locking screw, and I'll put that screw in its hole. And this just allows the plate to suck right down to the femur. It's not mandatory, it's just the way I do that. And so now I know that my rest of my screws, as they lock, it's held right down where I want that. And typically you'll get the locking screws down almost all the way and then use a hand tightening screwdriver to tighten them down. And at this point I will take the non-locking screw out and replace it with a locking screw. This edge has to be watched because you extend the femur. This will be sticking out posteriorly, once again towards the nerve. So you're usually going to want to cut that edge off. And it's not very difficult to cut off because you've already stripped the periosteum in the back. We'll reduce the plate to the bone using the reduction clamp. And you can see we've got some valgus here. And so this is that edge where we've only made a small correction here. When you make a larger correction, especially 45 degrees or so, this is going to be a very large bump. And so we're going to take that edge off. And so now this is going to be much flatter, and I don't have to worry about pressure on my nerve. And so now we'll fill the rest of these, paying attention to the rotation. Many of the children walk internally rotated. If that's the case, we will externally rotate the distal fragment. And so as the plate sits on the femur once again is not always round, you can make your very first screw a locking screw.
Yeah, I didn't even notice that. These are not compression screws.
And sometimes there is a step off here, and if this is made distal enough, it's not clinically very noticeable to the patient. And so this extension that we've created, this deformity up here, leads to the correction down here where the knee will now functionally be straighter, even though the correction has occurred just above the knee.